Hello and welcome to Regulatory Solutions. My name is Cameron and I will be walking you through this demonstration today. Today, this video is going to be showing you the SignalQual portion of our application. So that is the RF and planning tool, on all the utilities that we have that go along with that part of the program. So SignalQual can be a standalone application, but it is also built into the BDC application that we have. So if you are a BDC filer with us, then you automatically get all the capabilities of the SignalQual product along with that application. So there will be a few differences here. So in the map, there may be a couple of things that the BDC application has, such as the fabric locations and things like that. But SignalQual, for the most part, can do all the same things that the SignalQual portion of the BDC application can, with the exception of being able to show the fabric locations and all the information that goes along with those. Let's just jump right in here. What I have showing on the screen is the mapping portion, obviously. The first time you come into the map, it's going to be zoomed out to the whole US because it doesn't really know what the extents are that you want to look at. But every subsequent time you come back to the map, unless you have used a different browser or you're using a different machine, we do store the map location and the width of the map and everything. So what you're zoomed into, any layers that you have showing from our layer control, which we'll go into here in a bit, with the exception of the fabric. If you are showing the fabric, because it is a rather large layer and it's tiled, we don't show those. We don't put those back on the map when you first come in. But I think that's pretty much the only one that won't come up. So let's go jump into some of the newer features of the map, some of the visual features. We have the new toolbar up at the top here, and there are several different things that are going on here, so we'll explain that. This toolbar used to be a button here that would extend the toolbar down, and then you could select the options. But because we've added a few more, and most people are used to seeing toolbars in a GIS type application at the top, we decided to go ahead and place it up here. So let's go over these tools real quick. We have our normal map mode, which is basically just how the map operates normally. That's no special tools on the map. It just is going to allow you to zoom in and out, click on some of the objects on the map, get some information about them. We have our qualify site to point. So this allows you basically to qualify any points on the map just by clicking on the map. So if you click this and then you go out here and click any point, it will run a qualification to any APs that are within range of that location. So we also have the create polygon. So the create polygon allows you to determine or set which type of polygon it's going to be. So your technologies and the name, you can give it a name, and then the speeds that are going to be available within that polygon. We also have the routes. And so the same thing, if you create a polygon, when you create a route, again, you specify what it is, you give it a name, you give its speed up and down, and then you select the buffer distance around that. So this is going to create a polygon around these so that we can determine which homes are serviceable or which addresses are serviceable based on this buffer. And we also have a measurement tool. This allows you just to click on the map and get measurements along the map. So two new tools we've added here are the simple mode, which basically just only shows the profiles that qualify to a given location. And then we have the advanced mode, which shows all the profiles. So when we look at a location, we don't just try to determine the best server. We actually go out and we look at every AP that can possibly qualify that particular point or reach that certain point. And that's based on if you're within the coverage radius of the AP, and that coverage radius is defined by you, and also within the beam width or actually the antenna pattern, because we are using antenna patterns now. So if you are within that pattern and that pattern overlaps that location, then we will consider that a potential server for that location. So we will analyze that to see if it can possibly service that location. So for a given point, we may be looking at 5, 6, 7, maybe even 10 APs, depending on how you've built your network and how much overlap you have between those access points based on what you've set up in the system. So if you want to just see which ones qualify to it, then use the simple mode. If you want to see everything and see the analysis that we perform to see which ones could possibly hit it, then you would use the advanced mode. We also have this search bar, and you can search by an address. So this is just your typical, like you're putting in an address on, say, Google Maps or something. You want to find an address. It will do a look ahead for you and allow you to select that address. So if we put in something like 100 Main Street, it's going to go out and try to find where we are. Now you can bias this search. There's some map settings over here in the menu where you can set up your center and then a radius where you want to bias that search so it's not just looking all over the country. Also, we can search the locations. This is if you are a BDC subscriber. It will look at the fabric locations. We are actually adding the national address database as we speak on this demo. So within probably by next week, these locations, if you are not a BDC subscriber, will look at the national address database locations. You can also search by your subscribers if you have those in, or APs or towers. And again, this will bring up suggestions as you type for whatever you're searching for. That pretty much sums up the tools that we have available. And now let's get into some of the functionality of these tools. We also want to show you the layer control, which is pretty important because this allows you to display lots of different information. Let's go over that just a little bit. So we have, of course, our regular OSM or OpenStreetMap roads that we're showing when you first come into the map. We also have an aerial hybrid, of course, which shows you the satellite view or the aerial view. We have a terrain map, which only is available at certain zoom levels. Once you start zooming in, this kind of goes away. And then we also have our clutter map, and this is the 10-meter clutter that we use. So this is going to show you all the detail of the clutter around an area. And at 10 meters, it's pretty precise. So we actually think this is a little bit better than using LiDAR data. Most of the LiDAR data that's in use by other tools in the space is using just the first echo return, which means that it's going to show everything as terrain. So even your trees, your buildings, everything kind of shows up as just one big blob of solid object. And we actually think that using clutter is better than that, especially with some of the newer technologies, which actually have some really good capability to provide service at lower signal strengths. And so if you're just looking at clutter as a solid object, then you're not really able to determine whether or not that you can provide service if you happen to be grazing that or going through maybe a couple of trees or things like that. So we actually have a clutter loss model. And so we determine each category of clutter that your path might be going through. We determine the distance, the total distance along that path for that clutter. And then we apply a loss model. So that's a amount of dB per distance per some unit of distance through that clutter. So it's a little bit more accurate in our opinion. And we also now have a very, very high resolution down to 2-foot building resolution database, and that includes elevations of those buildings. So we not only know the footprint of the buildings now, but we also know the elevation. And that is actually much, much more precise than the LiDAR data, which again shows up as kind of a blob of terrain. And it doesn't really take into account what's on top of that terrain. It just sees it as a solid object. So with us having the building database in now, we can actually say, yes, there was actually a building here, a solid object, but it doesn't see trees and things like that. So we're able to make that distinction, which we think is pretty important. So getting back to the layer control here, we can show the CAF and RDOF auction boundaries if you're interested in that. We're not going to show those because they take a while to load. It is a national boundary set and it's not tiled, so it takes a long time. We show your subscribers now, whether they're licensed or unlicensed. And that is, of course, put in by you when you upload those subscribers to our database. And when you're putting in leads and things like that, those will also show up here. If there are leads, there would be another layer here for your leads. So, and that's important when you're using the self-qual portion of the program, which we'll go over in another video. So you can just see the different layers as we toggle these on and off. And we can also show you your census tracts here. If we zoom out a little bit, those will become a little bit more apparent. And this is important, especially in the BDC filing, because you do have to report subscribers by tract still, kind of like the old 477. And if you have people that are outside of this, it can possibly throw some errors. So we want to make sure that we have the right tracks and things like that. Really, this is more important for BDC than it is for just your typical network planning. Of course, we're showing the active sites. These are your towers. We just show these little tower for all the sites. We don't really distinguish between buildings and things like that. It's just basically like an icon to show you where they are. And then we have the APs. So we have what we call our active APs. And what this is showing is it's a uniform radius for every AP. We're not really taking into account your radius in this view. We're just showing you really kind of the direction and then, of course, the frequency of these APs, right? So each AP is colored randomly by frequency. So all the same frequencies will have the same colors, but it is a random color assignment right now. And we will be modifying that in the future to allow you to insert your own colors, but it just didn't come into production yet. So what these are, like you can tell, these little kind of pie shapes, what we're doing is we're taking the beam width of the antenna that you have in here and the radius that you define as kind of your well, actually, this is a uniform radius, and then we're just drawing kind of a pie shape to show you what direction those are facing and kind of where they're going to be on that site. So just a quick representation, and it doesn't make the map too busy. Now, the other thing that we have here is the APs by frequency, and what we're showing here is essentially the same thing, except we're now taking into account your defined radius for these. So you can see this map gets pretty busy. It's really hard to tell what's covering what because there's so much overlap between access points. And so it's really difficult to tell. But it's also helpful, especially when you can define these frequency colors yourself. And will allow you to turn on individual frequencies and things when we do that. So you can see where you might have overlap, where you might be facing the same frequency into another tower or directly into another antenna that has the same frequency. So you're kind of killing yourself with interference and that kind of thing. So that's coming. But in this instance, it's a little bit busy, a little hard to tell what's going on. So we don't recommend showing this very often. Now, for our boundary layers, we have the wireless bounds, which are basically just your coverage extents. And so what we do is we kind of take these AP frequencies, if you turn those on again, and we just kind of combine them all into one big blob. And this is really your coverage extents of your system, right, as defined by you and how far out you're covering from each AP. And this is useful just to kind of get a general idea of where you're going to be able to provide service. It also is what we use to clip the fabric data to do all our analysis. We certainly don't want to take into account this actually covers over a couple of counties. We don't want to have to look at every address in those counties because the counties are pretty big. And we would be looking at addresses way out around here. And of course, you're not going to be able to cover those. So it's kind of pointless to go out and do that. So what we do is we use your AP radii and combine them all together, create this kind of coverage blob, and then we clip your addresses against that. So if we want to see what that looks like. So here's the fabric data that we've brought in for this. And you can see we've clipped these addresses out from the fabric to only consider these addresses. So that's why we have that. So, and then we can also show the unlicensed, and if you had license, we could show those. We also can show your fiber bounds, and the fiber here, he only has one area in this location, or in this part of his network that is fiber right now. So that's the boundary that he uploaded to us. And I think he sent us a KML. We can deal with KMLs and shapefiles and things like that. But now that we have these drawing tools available, we highly recommend that you go in and draw them on the map yourself. And those layers you can see down here under the user layers. So once you create a polygon or a route, you can actually come in here and see these on the map as well. And I know this is pretty small, but you can see we've just done some test polygons in here and also some test routes. And so you can see these routes along here in these areas. So we also have under locations, so I showed you the fabric already. Let's go ahead and turn that back on. So here's your fabric locations. We also have the serviceable locations. So once we run your analysis, we can show you which items are now serviceable out of the fabric. So if we turn off the fabric, it's a little easier to see. And then we also can show you if you have fiber, DOCSIS, or DSL, whatever you might have will show up under these locations layers. And you can see which addresses you cover there as well. So we've already gone through these user-defined layers. So these are polygons and routes, so I won't do that again. Layer control, if you want to hide some of these sections, you can just hide them like this, or you can show as many as you want. Just makes it a little easier to see what you're looking at. There's a lot of options over here. Okay, now that we've shown you the layer control, let's go ahead and get into some of the functionality of the system. So one of the easiest ways to do this or show this is to go ahead and let's go ahead and put our serviceable locations back on the map. Once you have these serviceable locations, if you click on one, it's going to go run the profiles again for you that we ran to determine if this was serviceable. And then because we're in this simple mode, it's only going to show the APs that actually qualified to that location. And if we zoom out, if you're wondering what this area is, we're basically just showing again this AP coverage area. There were actually probably 2 APs on this tower that qualified to this location. So it gets a little darker because we're actually overlaying both of those layers. I like to turn off the area part of that because it does make the map a little busy. It's kind of hard to see sometimes. But you can see in here, we have this solid line. So anytime an AP qualifies to a given point, it's going to show you the path as a solid line. When we get into the advanced mode, I'll show you that if it's not qualified, it's going to show as a dashed line. But we'll talk about that in just a minute. So along this path, you can see it's a fairly short path, but you can see that we have some buildings here. And this is pretty interesting. So let's go ahead and take a look. So you can see kind of the building footprints in the OpenStreetMap, but this is easier to see if we use the hybrid layer. So we're going to turn that on. And a couple things to note. One, when you have a best server or best qualified AP, it's going to show up in this little gray window off to the side here. And this is your best AP for this location. It's telling you it's serviceable and its max speeds are 500 by 50. So pretty good. I'm not sure what technology this is, but of course we can see that as well. And it's all the information from the profile is in here. So this is showing you your distance, your bearing, both directions, right? The azimuth of that AP is pointing, the beam width of that antenna, the gain of this antenna, the frequency, the channel width, its transmit power, the noise floor that you've set for this, the RX elevation. So he has this at 40 feet, the gain on the receiver side, our free space path loss, any line losses. We always just kind of put a standard 2 dB line loss in there. We have a clutter loss, which is any clutter it happens to be going through. And you can see over here, we've got some trees at the end of the path. So our clutter loss was 14 or almost 15 dB here, based on the distance we traveled through that. And then, so our total received signal is -75. The minimum install signal, and these are all settings within the program that you set up. So you actually set up your by frequency and technology, you set up the minimum thresholds that you can achieve certain throughputs at. So that'll be demonstrated in another video, but just suffice it to say that you actually set up these throughput tiers. So get any given signal, we can go and look up and see what the maximum speed is you can deliver at this signal strength. So in this case, there's only one throughput tier for this, and that's 500 by 50. And he can service this all the way up to neg 80 on this particular site. And this is a Tirana, so that makes sense. So that's why. So this is a North Tirana Carrier 1. He has here listed as the name of this. So it makes sense that this would be able to service that throughput. Now, you can also see this same information if you click on a profile. So obviously, this is going to be the same thing we're looking at over here. But we're going to go ahead and cancel that out. One of the things I did want to show you, though, the reason I opened this aerial graph is these buildings. And this is pretty neat because you can see we're actually starting on a rooftop. So you can see that this, even though this is built up, these buildings are higher along this path. So we start on this rooftop, so it's a little bit higher. And then we're going along the path. And yep, look at there, we encountered another building. As we go along this path, still more. We encounter another building here, and sure enough, if we see on the map, our crosshair is crossing over this building edge right here. And as we go along the map, what do you want to bet? The next one is this building right in this area. And there it is. Sure enough, if we look at the crosshair on the map as we move along our profile, we are right there along the roof, and now we're off the roof. So now we're getting into trees right here. And if we look at our map, once again, there's a tree, and it's right there where we would expect it to be. So this is pretty nice to see. So we know exactly what's along this path. And obviously there's two, like again, there were two APs that overlapped to be able to service this location. So we got two profiles. So you can really see that the building database is pretty accurate here. It's really taken into account most of the buildings that we're encountering along this path. And obviously, these buildings aren't really affecting the signal much because we're so high above them. But if we were encountering these buildings, they would be considered a complete obstruction if we had to actually go through those. Let's go ahead and cancel this. Now let's take a look at the fabric, and let's look at some ones that didn't qualify. So let's go ahead and turn off the aerial hybrid. Kind of gets a little busy there with all these dots on the map and everything. So let's just pick one at random. So we're going to pick a location here. You can see that when we click on a fabric, it doesn't just automatically qualify. It gives us some information about it. And then if we want to qualify that point, we can go ahead and click it. And what it's doing is going out and looking at every AP within range and seeing if we can qualify to that address. Let's turn off the layer control here. And what you can see is that we didn't put it on advanced mode. And we know these don't qualify because they're still red. And so it brought up this alert for us here that says no APs qualified to this location. If you wish to see all the APs examined, change the qualify mode to show all APs. So basically it's telling us we got to put it in this advanced mode. I'm going to go ahead and turn off our layer control so it's not overlapping. So let's go ahead and put it in advanced mode. And then we're going to qualify this again. Now, you can see I'm going to go ahead and turn off these APs. And you can see now we've got several towers that we looked at on the map here. And you can see all these dotted lines. And these dotted lines are the paths that we looked at. And because, or dashed lines, I guess, because they're dashed, that's indicating they did not qualify to that location. Now, every once in a while, if you're showing the advanced mode, you may see a dashed line and or double dashed line, right? So it's just a line that looks like it's got two different colors. What that indicates is one of the APs on that tower did qualify and one didn't. So it's just the way that we can show that you did have something that qualified there and something that didn't. So again, you can see what we're going through here, why it didn't qualify. Here's one that really has some buildings that show up. So anytime you get these kind of red spikes along the way. That's a building that it's encountering. And of course, green are trees. And of course, the profile tells you what it is. As you move along the point, it tells you the categories there. It tells you your terrain, your clutter, your Fresnel 60, which is the 60% of your Fresnel zone clearance, and the line of sight. So all of the elevations along your path, plus the clutter category. So if you see up there the green dot where it says clutter, you can see that it is telling you the elevation and the category. So pretty useful information. Okay, now that we've shown you kind of that basic operation of these of the qualifications for these locations, let's get into some of the other tools on the map. So I'm just going to turn off these layers, and we're going to go ahead and escape to get rid of that pop-up, and then we're going to close the layer control. So let's take a look at the qualify site to point here. And I just realized that I misspelled qualify, so we'll have to take care of that. So what this does when you qualify a site to point, it wants you to put in a CPE elevation. The FCC, of course, wants us to keep things at 23 feet or below. And so we're just going to go ahead and put that in. Now, anytime we click on the map when we're in this mode, it's going to qualify us to whatever point we click. So I just clicked here. It does take just a second to go out and look at all the points. And we're still in advanced mode here. So we're showing everything that we're looking at. So you can see if we zoom out, we're looking at APs from all these sites. None of them actually qualified to this point. So let's take a look at just the simple mode and what happens if we click somewhere nearby. And once again, it's going out and looking at multiple APs. And again, we're in simple mode. Nothing qualified to the point we clicked. So it's telling us it's not going to show us anything because there's nothing to show if we're in simple mode. Let's go ahead and put it back in advanced mode and just click around the map a little bit and see if we can get one that has both qualified and non-qualified. So we're going to click up here in the north area somewhere. And this one has, no qualifications. So we can look at these and see why not. So if we click on a profile, it's going to show us, it says serviceable is false. And if we look down here at our signal, our total RX signal, it was negative 291. And that's mostly because of clutter losses, right? So if we want to look at this on the map, we can see along here that we had a bunch of trees right here at the end, which created a ton of loss for us. So that obviously is not going to work. And the same thing, this is another AP on the same tower. And the way I know that is you can see the crosshair on the map moving along as I move along this graph. So if I go down to this one, actually it looks like there were 3 on that tower. Here's another one. So this is actually looking at, if we cancel this, we're actually looking at a different site over there, kind of to the right. So I think you get the idea that you can see what's going on along these paths. So obviously that area is pretty much buried in trees, probably not going to service it at 23 feet. Now, if we want to look at a higher elevation, let's see if we can service it at 50 feet. And we'll just zoom in and try to click somewhere near the same area. And here we got one that worked. So from this site, you can see this double dashed line. And really what it is, a solid line with a dashed line on top of it. So, but it is telling us that we can service this location. So if we click on this, see it's telling us the serviceable is true. And our speed, our total received signal. Obviously, all we need is neg 80 to achieve this here. And we have neg 76, which is great. So, and no clutter losses because we now are above the trees because we went up to 50 feet. Now, if you want to put 50 feet up to get that, great. Otherwise, it's probably not going to be serviceable. So that's a good I guess, example of one that has both qualified and non-qualified points. Now, of course, if we Just go back to simple mode here. Let's get rid of this, and we're going to cancel our profiling. Just get rid of that stuff on the map. Let's just go click that area again, and we'll wait for the profiles to come through. And again, it's telling us because we're in simple mode, no AP is qualified to this location. So wherever we clicked was slightly different. It didn't even qualify at 50 feet. Let's see if we can find one that does qualify at 50 feet real quick. If this one doesn't, we'll just move on. There we are. So we got back to somewhere close to where we were. Obviously, you can see on the map here, we're just going right over the tops of these trees at 50 feet. So good for us. Okay, so let's go back to our normal map and let's cancel these profiles. So we've turned off our qualify tool. So now if we click around the map, obviously it's not really doing anything because there's no objects to click on here. Let's go ahead and take a look at, because this is very simple, our measuring tool. And you can see when we clicked our measuring tool, there's a little distance window that popped up down here at the bottom near the coordinates. And that's something I did forget to mention earlier, that anytime you move your mouse along the map here, it is showing you the coordinates of that point where you're moving your mouse. So down here in the bottom left-hand corner. So, but now that we've clicked on the distance tool, we can just start clicking on the map. So, and this is going to measure our distance. So you can see down there at the bottom right, down here, what the distance is of this line that we're drawing. And then as you click, it's going to give you a pop-up that tells you the distance from the previous point and then the total distance to this point so far. So if we click another point, now we can zoom in a little bit. Now we have the total distance is 1854 to this point, and then to our second point, we can see that the total distance is 4154.06. So, and it's distance from the previous. So it just keeps going. As you click points on the map, it's just going to keep adding these. And then down there at the bottom, as we get down here closer to the bottom left, you can see it's telling you your total distance and then the current distance of the segment that you're drawing. So this is useful, especially if you want to kind of estimate, the distance of how much fiber you've got to lay or something like that. It's, pretty rough, but as you zoom in, it gets pretty precise. So, and then if you just double click, it's going to stop the tool. And then you can actually start it again and start a new path. And so you keep getting these points. And so each path that you create or, segment that you create here will give you the totals as you go. And you can create as many of these as you want. So I can do another one here and just keep drawing points. If I double click, I've stopped another path. So it's telling me the distance and all these points. So really great little tool just to be able to measure some stuff if you need to. Let's go ahead and turn that off by clicking normal map. And then let's go over the polygon tool here. So let's just say I want to analyze an area, or I want to get all the locations in an area that are serviced that I know I can service with some fiber. So we're going to click fiber. We're going to give it a name and just say demo fiber. And let's just say we can service 1000 by 1000 in here. This is megabits per second. So that's 1 gig fiber. And we save this. And then now it's going to allow us to start drawing lines. So let's just go ahead and pick an area. How about this little place up here? And let's just say, okay, we know that we have fiber that encompasses all these streets. So if you click the same point you started, it's going to end the polygon, or you can double click anytime and that will actually close the polygon for you. So now we have this polygon, but let's say we messed up. We want to edit it. It gives you the points along this polygon. So maybe I need to stretch this one out. If you do that, it's going to add more points for you. So you can say, okay, well, I really meant to come up here. Great. Okay, so now that I've edited it, I'm going to save my edits. And now if I want to save this polygon permanently into the database, I just click save. If I want to cancel doing this, I can cancel it, or I can just delete this polygon and basically start over. So if I want to, once I hit delete, I can either cancel or save, and I'm going to say save deletes, and there we go, save deletes. Now if I want to edit it again, there's nothing really to edit, so I'm going to cancel it. I'm just going to cancel this whole thing, and we'll try it again. So fiber, we'll just call it demo fiber, and let's actually save this time. And again, we're going to put in 1,000, save. And then I'm going to draw this again. And like I said, if I double click, it's going to go ahead and close it for me. And now I don't really need to save or edit anything here, so I'm just going to say save it. You can now see it in the layer control down here, and there, sure enough, is this layer we just created. So the same thing can be done when we want to create a route. So if we just say, okay, this is a fiber route, we're going to call it demo fiber route. And again, we'll just say this is 1,000 up by 1,000 down. And we're going to go ahead and just leave this buffer distance at 200 feet. It's a pretty good buffer. And once again, we can start drawing our route here. And let's just going to stop it there. Let's go ahead and go down the street. And double clicking ends the route. Now we can add as many other points to this as we want. So if we have these streets as well, you can go ahead and just add these in here. And so what this is going to do is when we're done, it's going to combine all of these together. So again, we could edit these points if we want to. Obviously, if you drag points around, you can add more points to this. So if we just click here, you can add points, you can move this around, whatever we want to do. And we'll go ahead and save these edits. If you wanted to delete some points, you could delete, say, this route. Oh, yep, let's delete that. I'm going to go ahead and cancel that because we really didn't want to do that. And now, once again, we can save this. So that's how we are able to create new routes. Now, if we go back to our normal map, let's go ahead and turn off all these layers. Let's go ahead and look at the address search location here. So if we have our search set to address, we can go ahead and put something in like, I don't know, let's just see if there's a 300 Elm Street. Not in this area, is there? Okay, well, let's pick a street on here. There's a Grove Street up here, so let's say Grove Street. So there is, look at that, 300 Grove Street. So let's go ahead and choose this. And it's going to drop a pin on the map for this address. And let's go ahead and turn on our aerial view just so we can see what's around there. So this is Bing's interpretation of where this address is. So if we wanted to, say, qualify directly to a roof, we could. If we want to just see what's at this point, what qualifies to this point that it dropped, we can click on the point. It's going to give us the information. Let's go ahead and qualify. And there's nothing that qualified to that point. So if we want to see if something qualifies to a rooftop around here, we could always go back up to our qualify site to point. And let's just see if this rooftop will qualify. And nothing qualified. Of course, we have our CPE height set to 0. Let's put it at 23 and try again. And once again, nothing qualified to that address. So let's try something over here on maybe First Street. Okay, so here's a location. Now, Bing seems to be putting these into the streets. Sometimes it puts them right on the roof, sometimes it doesn't. It just really depends. But let's go ahead and try this again. Let's qualify. In fact, I'm going to go ahead and put our map mode back in normal. Doesn't really matter on this, but look, we did get one to qualify to this location. So we can see here, if we turn off our qualify APs again, you can see that it did qualify from this right here, this downtown site. And if we want to see what was on there, we can always click on the profile and get all the information about that path. So this one actually had two different throughput tiers. Don't know if you saw this down here, but we have 110 by 11, and that's at neg 65. And we also had 92 by 11, and that's at neg 70. So obviously we were under that neg 65, so we qualified at the 110 by 11. So since 63 is better than 65 in this case. Okay, so let's go ahead and turn off our layers again. I'm going to cancel this. And let's just go back to our regular map mode. And let's see if we can find some locations. It's always good because it still will find the locations, but they don't show on the map unless you actually have them turned on. And by locations, in this case, because this is a BDC subscriber, we are looking at BDC fabric locations. So you can search by address here. So let's just go ahead and put something like 300 First Street again and see what comes up. So it doesn't look like there's a location at 300 First Street, but if we just put First Street, let's see what we get. Okay, so here's the locations that the fabric thinks we have in this area. So let's go ahead and put 140 First Street. Let's just choose this one. It's going to center the map on that location. So that's probably this point right here. And if we look at it, here it is, 140 First Street. If we want to see if this point qualifies, again, we can just hit qualify. It's going to take just a moment and come out. And yes, look at that. It did qualify to this location. So that's how you would search for a location and qualify it if you wanted to. To get rid of the pop-ups, you just select the pop-up and hit escape. Let's go ahead and look at subscribers. And let's see if we can find somebody with the name of Jones. Doesn't look like we can. Let's see if we can find somebody on First Street. So here we go. There's somebody, again, at 114 First Street. So now this is doing obviously the name search doesn't work. We do have IDs and we do have the addresses. So that's what we can search by in here. Let's look at this person since it's a little bit different, 41st Street. So if we turn on our subscribers, again, this layer has to be on. And let's go ahead and just turn this on. And here's that subscriber on 41st Street. Now, if we turn on our fabric also, we can see if that matched. And this is something else to be aware of. When you see a subscriber that has a red ring around it, that means that that subscriber was not matched to a location in our database. So for some reason, this address is different. And you can see this, they have this address as 1005 41st Street Southwest. And we show this as 1005 41st Street Southwest. So something in here was slightly different. And so the addresses didn't match when we did our address matching, which has greatly improved, by the way. We have not run the new address matching on this data set. And so this probably would match at this point. But a tool we have in here is the ability to link any unmatched address. So in this case, for some reason, this 1005 41st Street Southwest did not match with this 1005 41st Street. And that's okay. It's a good opportunity to show this. So if we wanted to link these two together, we would click link, and then you can see it says select the fabric location you wish to link to this subscriber, and then click the link to customer. So now we click on the fabric link, and we would just click link to customer. And now it's created that link, and you can see this no longer has the red ring around it, which means that that location is now linked to this. But you can see that this customer, when they put this in, the lat longs that they put in for this were slightly different than the point that the National Broadband Fabric came up with. And if we look at the aerial hybrid, let's see who is more correct. So it looks like the customer probably put the coordinates in on the point on the roof where they installed the CPE, and the fabric just placed it in the middle of the structure. So this is the difference and why they didn't directly overlap on here. And it's pretty rare that you're going to see things directly overlap just because of this. The locations that we take from GPS or something like that don't always come out to the same structure location or the center of the structure or whatever CostQuest did to get this location point. So just another tool in the quiver. So we can also search by APs. I really don't know what his AP names are, so I'm just going to guess. Let's just put in AP. I bet he has that in the name somewhere, or I could be wrong. Anyway, you can search by APs. So here's something I put in 14. Oh, look, he does have that. This was just kind of a guess, but again, it's going to center that on where that AP's location is. And again, if we wanted to see those, we would have to turn that layer on the map. And now we can see which APs are at this location. So, and this allows us to see which AP this is by clicking on these. Unfortunately, this has an Omni AP, which rendered last, and it's covering all the others. So it's showing the same Omni AP for anywhere we click in here. Actually, it shows all the APs under this layer. So at this point, there are actually 1, 2, 3, 4 APs. And here we have 1, 2, 3 APs under where we clicked. So this is just showing you that we have multiple layers under this, or that point where we clicked. If we show towers, or we want to search for towers, let's go ahead and turn off our APs. Again, let's just look, since we know this is cell. You know, he names everything cell something. So let's find cell 18. And there's tower cell 18. So that's just a way to easily find some of your infrastructure if you need to get to that point on the map. So that just about covers most of the features available in the qualification tool that we have, our RF tool. So you can see there are several advantages, just to remind you of our tool versus some of the others. One, we don't use an area mode propagation, which means that we're not trying to go out to every single point on the map and determine what the signal is in, say, since we're using 10-meter clutter and terrain in a 10-meter bin, right? So little 10-meter squares. We're not trying to find signal everywhere. Instead, what we're doing is precise point-to-point profiles from every AP that could possibly service a location, and then giving you the best APs at that location. So instead of just doing some random, hey, you can get -60 signal, well, do you know which AP is providing that -60 signal? Do you know what throughput you're getting at that -60 signal? Do you know what technology you're using there? So these are the benefits of being able to do the path studies from every AP that could possibly hit that location, and then either having us, present one as the best server to you, or if you want to use some other criteria, you can actually examine all of those links yourself to see if you can determine which one is going to be the best for that particular customer. Obviously, terrain and clutter is only so good. You can't take into account every scenario, especially with things like varying tree heights. But because it's pretty high resolution, we can take into account most of what's there and give you a very, very accurate picture of whether or not you can service a customer, and not only whether you can service them, but which AP is going to service them the best. So if you have any questions about this, we encourage you to contact us and talk to us about it. If you'd like to see more, we can certainly set up another demo for you and walk you through this process. So thanks for watching today, and we look forward to hearing from you.